I grant the necessary permissions to the one DBA user. After that, I create a Java source that will take one argument, that is the command that we want to execute. And then create a Java store procedure that will call this Java method, so we can use it in a PL/SQL standard program. So we could execute this statement to override the sys password as any pass and to enable sysdba access, or we can use this other statement to rename the DLL file to disable database vault. Let's see how it works. Well, this script contains the same instructions we just seen in the slides. So we have the DLL file with the correct name. We are going to execute the exploit. And we will see that the DLL file will be renamed. Well, the way to defend from this attack is to restrict the Java admin role. That is the role that is needed to grant the Java permissions needed to access operating system resources, or to remove the Java support from Oracle database if we don't need it. Let's see if, well, as we can see now, the DLL files has an underscore, so it's the database vault will be disabled. So we were able to disable database vault having the Java admin role. Let's see now a way to do this with no privileges. It is needed just these two statements. The first one gives the necessary permissions, grant the necessary permissions to the user that is exploiting this vulnerability, and then we just use this function to call the Oracle Aurora util wrapper class, the main method in that class, and we just execute the operating system, pass as argument the operating system command we want to execute. Yeah, no, I will just show that it gets renamed. I won't restart and start it again. So the DLL now has the correct name. After I execute this exploit, we can see that the DLL file got renamed. So to defend from this attack, the one that doesn't use any privileges, we should apply the April 2010 CPU that fixes the Java vulnerabilities that allow to grant the Java permissions, even if we don't have the Java admin role granted. And or we could revoke the privileges from this DBMS JVM experms package that is the one that is used to grant the Java privileges. Well, let's see now an example how we can get operating system access and disable the database vault with a buffer overflow attack. This buffer overflow is in a store procedure, so we need execute permissions on a vulnerable store procedure. Well, this is the exploit. I won't enter much into detail. The vulnerable parameter is the dir path parameter. So when the buffer overflows, the EBX register points to the start of this dir path buffer. So here I enter the instructions that I want to execute, that basically are a call to the system function of C runtime library, and then the end thread function, so that the threads end and there are no exceptions thrown after it continues with the execution. Let's see how it works. I will use 10G release 2 Oracle because this vulnerability is in that release. So we have the DLL file with the correct name. And as we can see, the file got renamed with an underscore. So now the database vault is disabled. Well, to defend from these buffer overflow attacks, Oracle fixes these buffer overflow attacks, the one that researchers report to them, or the one that they found internally with critical patch updates. So we can apply CPUs to be protected from known buffer overflow vulnerabilities. Also, it's important to reduce the attack surface, so we should restrict the execute permissions on packages, because there are a lot of packages with buffer overflow vulnerabilities. Let's move now to the impersonating MACSYS attack. This one requires create any procedure and execute any procedure privileges. So it basically has two steps. First one is to create a procedure in the MACSYS schema, and then we just execute this procedure which has created. As we know, the Oracle by default executes the store procedures with the privileges of the owner of the schema. So if we are able to create a store procedure in the MACSYS schema, we can execute statements as this MACSYS user. Here is the example. We just prefix the store procedure with the MACSYS schema name. So this procedure takes a statement as an argument and executes it. After we have this statement, this procedure created, we can call it and with a SQL statement as its parameter, and it will be executed as the MACSYS user. Let's see. So here the script first create a test user and grant the required privileges to exploit this problem. We then connect as this user and create the store procedure in the MACSYS schema and then call it to change the password of the MACSYS user. As we are impersonating the MACSYS user, we are able to do this. If we are not a MACSYS user, even if we are DBAs, we can't change its password. And then I'm going to show that you can now connect as MACSYS with this new password. Well, as we can see, here first I connect here. Here I can connect now with the MACSYS any password used, any PSW password. Well, there are a couple of things we can do to protect from these attacks. First, we can restrict the privileges that are needed to perform this attack, that are the create any procedure and execute any procedure privileges. We should consider also to protect the MACSYS schema with a realm. We can do that by executing those SQL statements. If we have the MACSYS schema protected, then even if we have the create any procedure privileges, we can compromise the MACSYS schema because it is protected with a realm. Well, there are some considerations that are documented for the SYS user. But it's actually, the documentation doesn't say much about how the SYS user can compromise. So I researched it a bit and found that it can compromise using this parse as user store procedure that can impersonate the MACSYS user. So we can alter the MACSYS password. And also in other releases, the MACSYS user can do some other things like directly update all the data dictionary table. So for example, we can, if we are the SYS user, we could update the MACSYS password using this statement, or we can grant the DB owner role in adding a row in the sys auth dollar table. So what about SQL injection in sys schema? If we can impersonate the sys user using